Welcome to a journey through the cosmos, exploring the ultimate question of our existence. You are watching Black Hole Basics today. Look up at the night sky and imagine the billions of stars burning brightly in the vast darkness of space around us. For centuries, humanity has looked at these distant lights and wondered if anyone else is looking back at us right now. Are we merely a cosmic accident, or is the universe teeming with life waiting to be discovered by our curious minds? Astronomers estimate there are between 100 and 400 billion stars in our Milky Way galaxy alone, a staggering number. When we consider the entire observable universe, the number of stars becomes almost impossible for the human mind to truly comprehend. The Kepler Space Telescope has revolutionized our understanding, showing us that planets are actually very common companions to the stars above. By watching for tiny dips in brightness, scientists have confirmed thousands of worlds orbiting distant suns, many similar to our own. These exoplanets come in all shapes and sizes, from rocky worlds like Earth to massive gas giants larger than Jupiter. But simply having a planet is not enough. Location is everything when it comes to the potential for sustaining complex life. This is the habitable zone, the region where temperatures are just right for liquid water to pool on a planet's surface. Water is the universal solvent, the essential medium where chemical reactions necessary for life as we know it can take place. Data suggests that roughly 1 in 5 Sun-like stars might host an Earth-sized planet within this crucial habitable orbital zone. That translates to potentially billions of habitable worlds right here in our own galaxy, waiting for life to take hold. Beyond water, life requires the right chemical ingredients, specifically carbon, which is abundant and capable of forming complex molecular structures. Spectroscopy reveals that the building blocks of life, like amino acids, are found in interstellar clouds throughout the vast universe. Comets and asteroids may act as cosmic delivery systems, transporting water and organic materials to young planets ready for life. This theory suggests that the ingredients for life are not rare, but are actually scattered everywhere throughout the cosmic dark. On Earth, we find life in the most extreme environments, from boiling volcanic vents to the freezing depths of polar ice. These extremophiles prove that life is incredibly resilient and can adapt to conditions we once thought were impossible for survival. If life is so resilient, could microbial life exist right next door on Mars? Or perhaps in the oceans of Europa? Europa possesses more liquid water than all of Earth's oceans combined, hidden beneath a thick crust of protective ice sheets. In 1961, astronomer Frank Drake formulated an equation to organize our thinking about the probability of extraterrestrial civilizations. The Drake equation is not a solution, but a framework to estimate the number of active, communicative civilizations in our galaxy. It starts with the rate of star formation, a number we have pinned down with reasonable accuracy through modern astronomy. Next is the fraction of those stars that have planetary systems, which we now know is nearly 100%. Then we look at the number of planets per system that could potentially support life, based on their distance and composition. The next variables are trickier, the fraction of habitable planets where life actually begins at some point in its history. Then, on those planets with life, how often does complex intelligence evolve? This is where our uncertainty begins to grow. We also need to know the fraction of civilizations that develop technology that releases detectable signs into space, like radio waves. Finally, the most critical variable is L. How long do these advanced civilizations survive before they collapse or destroy themselves? Depending on the values you choose, the galaxy could be teeming with millions of friends, or we could be completely alone. The rare Earth hypothesis argues that while microbial life might be common, complex intelligent life requires an incredibly lucky sequence of events. Our large moon stabilizes our tilt, preventing chaotic climate shifts that could wipe out developing life forms over millions of years. Jupiter acts as a gravitational vacuum cleaner, sweeping up dangerous asteroids that might otherwise bombard Earth and sterilize the surface. Plate tectonics recycle carbon and regulate our temperature, a feature that seems to be unique to Earth and our solar system. Earth has maintained a stable, habitable climate for 4 billion years, a feat that might be incredibly rare in the universe. Look at Venus. It is similar in size, but turned into a hellscape, proving that size and location are not everything. The leap from simple chemistry to self-replicating DNA is a mystery that science has yet to fully explain or replicate. Even if life starts, it took billions of years for single cells to evolve into complex animals and intelligent beings. For most of Earth's history, life was nothing more than slime. Intelligence is a very recent and perhaps accidental development. This brings us to the concept of the Great Filter, a barrier that prevents life from reaching the stage of space colonization. Is the filter behind us, meaning we are special, or is it ahead of us, meaning we are doomed to fail? Perhaps advanced civilizations inevitably destroy themselves with their own technology before they can ever make contact with other worlds. For decades, the SETI program has been listening to the radio silence of the universe, hoping to catch a stray signal. So far, our searches have returned nothing but silence, a haunting lack of evidence that leads to the famous Fermi Paradox. Physicist Enrico Fermi famously asked, "If the universe is so vast and old, why haven't we seen any aliens yet?" A civilization just a few million years older than us should have colonized the galaxy, leaving signs everywhere we look. We look for Dyson spheres, massive structures built around stars, but we have found no conclusive evidence of such engineering. The James Webb Space Telescope is now hunting for biosignatures, analyzing the atmospheres of exoplanet for gases like oxygen and methane. Finding these gases together would be a strong hint of life, as they react quickly and must be constantly replenished. We must also consider that alien life might be so different from us that we fail to recognize it entirely. Perhaps advanced civilizations have shed their biological bodies and exist as machines or pure energy, invisible to our telescopes. Or maybe we are in a cosmic zoo, being observed by advanced beings who have chosen not to reveal themselves yet. The silence is frightening, but it is also a blank canvas for our imagination and a driver for our exploration. We have sent our own messages into the dark, like messages in a bottle, hoping someone, somewhere, will find them. Whether we are alone or not, the answer has profound implications for how we view ourselves and our fragile home. If we are alone, then we are the universe's only way of knowing itself, making our survival even more important. If we are not alone, then we are part of a grand cosmic community, waiting for us to grow up and join. From the chemistry of stars to the biology of cells, the path to life is complex, dangerous, and utterly miraculous. As we continue to gaze into the abyss, we are searching for a mirror, hoping to see a reflection of ourselves. The search for extraterrestrial life is just beginning, and the next few decades promise to be the most exciting yet. With better telescopes and smarter algorithms, we are getting closer to answering the question that has haunted us for millennia. Every star is a sun, and every sun could be a home. The possibilities are as infinite as space itself. Life is the universe's way of waking up. We are the eyes of the cosmos, looking back at its own creation. Someday, we may not just look through telescopes, but actually set foot on these distant worlds to see for ourselves. Until then, we rely on science, logic, and a bit of hope to guide us through the great cosmic dark. 100 billion planets in our galaxy alone, yet we have zero proof. The math and the reality do not match. We must remember our own planet froze over completely multiple times, nearly extinguishing all life before it really got started. Without that asteroid hitting Earth 66 million years ago, dinosaurs might still rule, and we would not be here. Evolution is not a straight line to intelligence. It is a chaotic game of chance played over billions of years. High intelligence exists in dolphins and elephants, but they do not build radio telescopes or launch rockets into deep space. The combination of intelligence, manipulative hands, and culture might be a unique set of traits found only on this planet. There are also rogue planets drifting in the dark, kept warm by internal heat, potentially hosting life in eternal night. Scientists also speculate about silicon-based life, which could exist in environments too hot for carbon-based biology to survive. On Titan, Saturn's moon, would methane flows like water. Could life exist there using a completely different chemical operating system? As we learn more, we constantly update the Drake equation, narrowing down the possibilities, but never quite reaching a certainty. The longevity of civilizations remains the biggest unknown. Do they last for millennia, or burn out in just a few centuries? Our own struggles with climate and war suggest that reaching a stable, long-lasting technological state is incredibly difficult to achieve. Some theorize the universe is a dark forest, where civilizations stay silent to avoid being hunted by powerful, hostile predators. If this is true, then broadcasting our position to the stars might be the most dangerous mistake humanity has ever made. Stephen Hawking warned that meeting an advanced civilization could be like Native Americans meeting Columbus, which did not end well. On the other hand, contact could bring solutions to our greatest problems, leaping our technology forward by thousands of years. New mega telescopes are being built right now that will be able to directly image exoplanet and analyze their air. Imagine seeing a blurry blue dot in a telescope and knowing for a fact that it is another living world. Such a discovery would fundamentally change our philosophy, religion, and understanding of our place in the fabric of the universe. However, knowing they are there and actually reaching them are two very different things due to the immense cosmic distances. Unless we discover physics that allows faster than light travel, we may be destined to simply watch each other from afar. A conversation with a civilization 1,000 light-years away would take 2,000 years to receive a single reply. This search requires patience spanning generations, a project for humanity as a whole, rather than just individual scientists or nations. Perhaps we will become the aliens we are looking for, spreading life to Mars and beyond in the coming centuries. We might inadvertently seed other worlds with our own microbes, starting the cycle of evolution on planets that are currently dead. We are the custodians of the only known life in the universe, a responsibility that weighs heavily on our collective shoulders. This perspective drives home the point that Earth is unique, at least for now, and worth every effort to protect. The recipe for life is complex: mix chemistry with energy, add water, and bake for billions of years with luck. We are made of star stuff, the universe organizing itself to wonder about its own origin and its potential companions. The question remains unanswered, but the search itself drives our technology and our understanding of physics to new, greater heights. Global collaboration is increasing, with nations sharing data and resources to scan the sky more effectively than ever before. Projects like Breakthrough Listen are scanning millions of stars, vastly increasing the odds of detecting a signal in our lifetime. Artificial intelligence is now joining the hunt, sifting through mountains of data to find anomalies that human researchers might miss. A century from now, we might look at a map of the galaxy and see it populated with known living worlds. Or we might find we are truly the first, tasked with the grand destiny of waking up the rest of the universe. Either possibility is awe-inspiring and terrifying in its own way, forcing us to cherish the life we have right here. Curiosity is our defining trait. As long as there are stars in the sky, we will keep looking up and wondering. We have explored the numbers, the chemistry, the biology, and the paradoxes that define the search for life beyond Earth. Now, turn the question over to you. Do you believe the galaxy is full of life, or is it empty? Let me know your favorite theory about the Fermi Paradox in the comments below. I read every single one of them. If you enjoyed this deep dive into the cosmos, please hit the like button and share this video with fellow explorers. Check out our other videos exploring the mysteries of black holes and the origins of the universe on our channel page. The universe is full of mysteries waiting to be solved, and we are just scratching the surface of what is possible. Thank you for spending your time with us today and joining this fascinating conversation about our place in the vast cosmos. Keep looking up, keep wondering, and never stop exploring the infinite possibilities that surround us every night. See you next time. This has been a production of Black Hole Basics. Subscribe for more science and mystery. Goodbye and safe travels, space cowboys.